Hi, everybody. My name is Katelyn, and today we're going to be talking about isotopes. Isotopes are a pretty simple concept once you take into account the structure of the atom. And what an isotope is one of the two or more forms of an element, and it has to be the same element in order to be an isotope, with the same number of protons, but a different number of neutrons in the nucleus. Now, remember about the structure of an atom. You have the nucleus that houses both the protons and the neutrons, and then you've got the orbitals surrounding that nucleus that house the electrons. So when you're talking about isotopes, you're really only talking about what's inside the nucleus. So if you look at this diagram down here, we have a carbon atom, and then these two numbers to the side of it. Now, what these two numbers represent is this number on top is the mass number. And then the number on the bottom is the atomic number. So this basically refers to, the mass number refers to the number of protons added to the number of neutrons. And then the atomic number is simply the number of protons. And remember, the atomic number is actually written on the periodic table. So when you need to find the atomic number, you just figure out what the atomic number is off the periodic table. Now, this is actually one way to write an isotope, but you could also write it like this. So carbon, if you spell it all the way out and put a dash to the mass number, so carbon 14, this is another way to write. And from here, you can actually figure out a lot. So like I said, the atomic number you can find off of the periodic table. And then this is not a charged atom at this point. So it would have to have the same number of electrons. So you're also going to have 6 electrons. And then, like I said, the mass number is the number of protons plus the number of neutrons. Before I explain a bit more about that, think about why that is. Electrons have a pretty negligible mass when it comes to the overall mass of carbon. So we just add the number of protons plus the number of neutrons to create this mass number without a ton of decimals after that number. So from here, if you were to just have 14 and you knew that carbon had 6 protons, you would subtract 6 from 14 to get 8 neutrons, which is the number of neutrons in carbon 14. So that line of reasoning is something that's really common on tests and quizzes when you're talking about isotopes. So I'm going to go ahead and scroll down a page and show you, this is a periodic table, and then this grid down here. This is a really common way for teachers to ask questions on exams. So we're going to go ahead and look at uranium-235. And here it's asking for the atomic number, the mass number, the number of protons, number of neutrons, number of electrons, and the isotope notation. And that notation is what I just showed you up there with mass number over atomic number and then the element symbol. So uranium-235. So what do we already have here? Like I said, we have the mass number, which is 235. So let's go to the second column. All right, then let's find uranium on the periodic table. I'm going to go ahead and highlight it for you. It's down here. So we see here up in this top corner that the atomic number is 92. So that is going to be uncovered here. There's your atomic number. Now, what is the atomic number? Remember, if you refer back to the last page, it is the number of protons. And then if you were to take 235 minus 92, that's your number of neutrons, and that should be 143. And then finally, number of electrons. Remember, this is not a charged atom. So the number of protons and the number of electrons must be equal, which means that this is also 92. Then notation-wise, remember, it is mass number, which over here says it's 235, over atomic number, which is 92. And then your element symbol. So 235 over 92, uranium, U. That's your isotope notation. So let's do the same thing a little bit quicker now with uranium-238. Mass number is 238. Let's uncover mass number. Then atomic number, we know that's 92. We know that the number of protons is also 92 because that's what the atomic number is. Then 238 minus 92 is going to equal 146. And then again, not charged, number of electrons also has to be 92. So this is going to be 238 because that's our mass number over 92. uranium. Now notice these two right here, so uranium-235 and uranium-238, these would be isotopes of one another because they have the same number of protons, they're the same element, and they have a different number of electrons, or a different number of neutrons, and therefore different mass numbers. Same thing's happening here with boron-10, where the atomic number is, or the mass number is 10. And then we're going to find boron on the periodic table. It should be right here. We see that the atomic number is 5. So number of protons has to be 5, number of neutrons has to be 5. And finally, the number of electrons also has to be 5. So this is going to be 10/5 boron, which is just B. Then the last one, atomic number will be 5 because that's the number of protons. Mass number is going to be 11. Number of protons is going to be 5. Number of neutrons is 6 because that is the mass number minus the number of protons. Then finally 5 for the number of electrons. So that is 11/5 boron. And once again, we have isotopes of one another because they have the same number of protons, but a different number of neutrons. So that's your crash course on isotopes. Feel free to reach out if you have any questions or visit the Rinella Center for further help. Good luck on your next test and quiz. Thank you guys so much for listening.